In this video, we explore if a derived class inherits the friend property. In C++, you use the keyword friend inside a class to allow a function outside the class or under the class to access your private members. In other words, friends can see your privates. Actually, it's much worse. The only reason to befriend in C++ is to give access to your privates. That's the only benefit of friendship in C++. Also note that friendship is one-sided in C++. If bar is a friend of foo, it doesn't mean that foo is a friend of bar. Only bar can access foo's private, but not the other way around. Let's take a look at an example of a friend function. We have a class foo with private member n. Also, we have a function f1 that takes a class f of type foo and tries to set f.n to 0. If you try to compile this, you will get a cannot access private member error. If you add the function definition of f1 as a friend inside foo, then it compiles fine. Next, let's look at an example of a friend class. Here we have the class bar, which has the function f1 inside it. If you try to compile it, we get the cannot access private member compiler error. If you declare bar as a friend of foo, it compiles fine. Let foo junior be derived as public from foo with its own private variable m. Note that bar.f1 can access foo junior's n. However, bar.f1 cannot access foo junior.m. So bar is still a friend with the foo part of foo junior, but not with foo junior itself. If the inheritance is private, then bar loses access to foo junior.n as well. Now let's look at bar junior, which is derived from bar. It doesn't have access to n from either foo or foo junior. So in this case, bar junior doesn't get bar's friend property. Thus, in general, friendship is not inherited.